Okay, so maybe we could start. So, welcome to the AutoGIS course, and to the latter part of this lesson where we actually now start doing some real GIS stuff with programming. So, at this point, you should have some basic skills about programming in general, using Python and some data analysis stuff as well, using pandas. I was away last week, so unfortunately I didn't manage to respond to much of your worries and questions in Slack. But tomorrow there will be an extra session for those who have struggled with the exercises 6 and 7 of that week. So if you can be around at 4, so we can help you out, and I will also be more active on Slack as well. Yeah.
Will we continue on the same Slack channel or have a new one?
Yeah, we were thinking about whether we create a new Slack or just continue this one, but I guess we are going to do using the same Slack team. We just separate the AutoGIS and the Intro QQ Quantum Qualitative Geology, not quantitative geology course, so they will be on separate channels there. So just check that which one you belong, which course. So just put your questions there. So we will be doing that. In here, you see the new website. So we have separate website for the course. You can find it by typing the autogis.github.io, and it will direct you to this website for this year. We had a similar website for last year as well, and the materials are there. So if you're interested of what might be part of this course as well, you can check the materials from there, but I will be updating the materials. So yeah, so don't look at those and do the exercises from last year because they might change. So just that you know. But the overall, the website will be similar. So we have the tutorials for each lesson available, and I'm also recording the videos now. So also those should be available if everything goes smoothly. I hope so. I haven't done these video recordings before. It worked all right with Dave, but let's see if my Windows version works as good as in last period. But in general, so from the course website, we can take a look at the contents of this latter part of the course. So what we will have is that we again have 7 lessons in the course, and we will kind of continuously build our skills to do GIS stuff using Python. So we start up with really kind of basic spatial data models. So you need to understand what kind of spatial data objects are available, and these kind of, well, geometric objects. So the stuff that you do in ArcGIS and the spatial features there. So in Python, we kind of need to have a special data types that actually store that information and have different attributes available for doing different kind of GIS operations, such as nearest point or whatever. So we start by going and seeing what kind of geometric objects are available in Python using this Shapely module that provides all of those things. Then next week we will kind of start doing work with geodata frames. So in last period we saw how you can manipulate data and do data analysis with pandas. Now we are moving to GeoPandas, which is kind of a new framework built on top of GeoPandas. So it works in a similar manner, but in that in GeoPandas you can do all sorts of GIS tasks quite easily. So next week we will talk about that. Then we will go through these kind of basic GIS tasks that we quite commonly need to do. So geocoding is one. So if you have addresses, you want to put them on a map. So how do you do that using Python? And how you do some simple spatial queries such as point in polygon and these kind of things. So all these stuff can be done using just pure Python. You don't need any ArcGIS for doing that. Then we move forward to doing simple geometric operations such as aggregating and doing overlay analysis and doing some reclassification with Python, which is one module used for GIS and this kind of spatial analysis. This reclassification is basically the same stuff that you really often do when you visualize data. So you define natural breaks or these kind of different classes for your visualization. So this Python provides all those tools for you. Then on class 5 we do maps. So that's basically we will focus just like seeing how you can create maps using GeoPandas and Bokeh, which is this kind of framework for doing interactive visualization. So we will basically do and see how you can actually publish interactive maps on a web using Github and then how you actually can create those. So after that week you should be able to do some cool interactive maps as well. Then class 6 we will see how you can do and use Python programming in Quantum GIS. And Chris, he is our new PhD student at our group, so he will be showing you that. So he has done a lot of programming related to Quantum GIS and developed tools and plugins for Quantum GIS. So he's way better guy to discuss about and teach you that kind of stuff, and I will hopefully also learn from him. So it's at the beginning of December, and on the last week we will kind of end this module by or this course by showing you how you can do network analysis using Python. So you don't necessarily need to use ArcGIS network analyst for doing things. You can also do it using Python. So that is what we will focus on that week. As you might see, there is not much about raster processing. We had it last year, but we decided to leave it out because we had so few time to actually go through raster. So it's a totally different world. So hopefully if we have resources and time, we will basically create a new course just for raster processing, because all the stuff are somewhat works a bit differently than in vector processing, and you have different tools for that. So we decided to leave that out. There is some stuff on last year's materials that you can find a link from here. So if you're interested, you can take a look what we did last year with this raster stuff. It was only one lesson, so not much really. Cool, but that's it. Then as a kind of how you will be created and what you will need to do. So we don't have any kind of well, we have exercises, but we don't have any exam. So you don't need to actually take a piece of paper and do coding as they do here at computer science, which is quite interesting. But how you will be created is based on the exercises that you have done, and then we have this kind of larger assignment, like final assignment that you need to do. So I can show you actually what we did last year, so you can get get a kind of idea what it includes.
Is there any link to that website?
Yeah, so there is actually a link. So on the kind of landing page when you come to the site, there is a earlier version. So
Oh, I mean that AutoGIS new versions. It's on the board.
yeah, there is the link to this. So yeah, it's autogis.github.io.
If you find a 2006 version, then you can just change the path to 2017.
Yeah, so basically it will follow the same structure. So there is the year here, and then you can change. Yeah, but the final assignment, so basically what the students did last year was this kind of accessibility visualizer that basically does all sorts of things, and you kind of need to do it yourself. Let's see if we do the same this year. Might be not, but I will kind of decide it later when we continue and see where we are. And then the other option last year was to create a project of your own. So as said, the idea of this course is just we don't like expect you to solve specific type of work. The idea is that you learn these techniques and you learn to use them and apply them. So basically, if you have any good kind of idea of your own, what you would like to try to do with Python, so that's all welcome. And basically, if you have those ideas, just give me, like, share it with me, and then we can see if that's appropriate for this own final assignment for you. Last year there was only one who did it, but anyway it worked okay. So one student had an idea that he wanted to kind of apply these stuff for his own problem, and then he did it, and it was okay.
Does it need to be GIS related?
Yes, it needs to be GIS related, and basically so that you need to kind of show your skills from these stuff that you learn in this course. So that's the kind of introduction to the course, the latter part of the course. So you will find all the information on the website and so on. So as you probably noted, we are in different classroom. So we will be here. I guess it's this C122. So every Monday from 12:15 to at 4 until 4. It might be that we don't actually. It doesn't take that long to go through the materials, but at least we have the time if needed. And then again, we have the work sessions on Thursday, so they will be on the same classroom, GitLab, GIS labs at Physicum every Thursday from 12 to 4. Yes, you have.
Are the exercises on Github like the
Yeah, so the exercises will be on GitHub in a similar manner as on period 1. So we will be using this GitHub classroom in a similar manner. They are now we have a separate organization, so they are actually distributed using different websites. For this week, the GitHub classroom is not available yet. I will put it as soon as I get the permission from GitHub to get these student private repositories. So at the moment it works so that if you would do it, all your repositories would be public, and we don't want that. So it takes maybe, hopefully today I will receive already those. So
yeah, but the exercises there are like the real ones and not last year's.
they are the
link for the exercises.
yeah. So these are the ones for this year. So
Good.
So it will be.
That was kind of my question.
Yeah. Okay. Sure. Yeah. Good. Cool. Do you have any questions about, like, general questions about the course? Anything? No. how did the last exercises went with the last?
That was much work.
So yeah,
Huge amount of work.
yeah, that's good. Yeah. They were more difficult for sure, because now we started doing some real analysis, and then because we also were having some time pressure issues when doing those, so also maybe the instructions weren't the best. So I'm sorry about that, but hopefully you kind of managed to understand what we wanted and managed to do them. So as said, tomorrow we have an extra session for those who are struggling with the exercises. Cool. But I guess we could kind of move on and start doing the GIS stuff. So first of all, you all need to install some packages to your Anaconda, so the spider. So basically I will first show you the basic principles how you actually can install stuff for your own computer, and that might be really useful in general, because it's fairly easy to do, but you need to kind of understand few basic things. So there is a separate section on the course website under here, the course information, called Installing Python plus GIS. So it looks similar as in the earlier course, so GeoPython website. So you all should already have this Anaconda installed, so you don't need to worry about that. But then there are these commands, quite a few of them. We don't necessarily need them all, but you might want to install them all because they are all really useful for doing different GIS tasks. And some of them you already have installed, such as this NumPy and Pandas, but they are here anyways. So these are such that you should install first. We might on Thursday, so if you have troubles in doing this, so you can come on Thursday and we will do this then, and I will instruct you if you have any troubles, but it should be quite straightforward how we can do this. And the key is that with Anaconda, so this spider IDE is part of this Anaconda Python distribution package. So with that tool or this package, there comes this nice little tool called Conda. And this Conda is such kind of, it's similar to what R does, that you can just install all sorts of libraries directly from R. In Python we do it a bit differently, so we are actually using the command prompt for doing that, or terminal in Mac and Linux. But basically how we can do that is that if I type CMD in Windows and search for that, we can find this command prompt from here. In Finnish it is komentotulkki, if someone get it. Then the important part is to run this command prompt as administrator, because only that way you have the necessary rights to actually do the installation. So you should basically, whenever doing the installations of different modules in Python, you should run this as administrator, and then it asks that, do you give permission to do, and blah blah blah, and I say yes. So then we are basically having this command prompt with administrator, so you can basically see it from here that we are now running this as an admin. Basically we could first check if the Conda works, so we can check that out by typing Conda -- version, so it should print you with the current version of Conda, and if this happens you should be sorted and everything should work. So how you can basically install these packages is just opening the command prompt as administrator, and then we can just basically copy and paste these or write them. So basically the typical way of installing packages in Python using conda is that conda install, and then you basically can you by the way see this? Is it? I can maybe try to put it a bit larger. Now you should at least see it. Yeah, so you put conda install and then the name of your package. So for example, well, let's put pandas because that is a module that you already know quite well. So if I press this, it basically fetches all the stuff from internet and also sorts out all different yeah, this is what it does. So it checks what kind of versions you have from different packages, and then it kind of finds the correct ones, updates all those that are needed to be updated, and so on. So this kind of does a lot of work that makes our life much easier. So in this case, I only update my pandas to a newer version of this. But in a similar manner, you can basically install all these packages using conda. There are a couple of packages that needs to be installed using pip, and pip is a similar kind of package distribution manager that comes with Python by default. It doesn't check anything like are these different versions of different modules, do they work together or not, so it doesn't do that. So conda is a bit better tool for doing the installations in that sense. Cool. But basically we could, when we have a short break, those of you who have computers, we could see if you can actually get this working, and then you can already start following the lecture if you're interested. Cool. So that's about installing stuff. Then about the intro. So basically what you will learn during the latter part of the course is, as said, to kind of know and understand and have different skills to do all sorts of GIS tasks with Python. So of course you will learn how to read and write spatial data from and to different data formats. You will learn how to deal with projections, so the really basic GIS stuffs, and then do different geometric operations, reclassify data, spatial queries, and do simple spatial analysis and routing and such. And the kind of coolest part, as most of us are geographers, so we like to do maps. So basically after 5th week you will learn how to do these kind of nice interactive maps that you can actually zoom in and do all sorts of, and you have this nice interactive kind of box showing the data values from these cells and so on. So this is kind of neat what you will learn. And then why Python for GIS? Why are you here, by the way? This is you all want to learn programming and GIS programming. Do you have any kind of thoughts about why you would like to learn?
Yeah, for me it's for my master's thesis, and also I think that if you're using GIS and you're just using it like pushing buttons, then you're just a button pusher and you can be sort of easily replaced by an AI in the future.
Yeah.
So understanding the underlying code is sort of a very crucial thing to keeping your job, I think.
Yeah, that's good. Any other? Yeah.
Yeah, there are also many things that you can't really directly do with ArcGIS or Quantum GIS. So
Yeah.
if you want to do something that is a bit like finer or more complex, you need to like know
Yeah.
some Python.
Yeah. Yeah, those are both really good answers. And really, yeah, the name of the course is Automating GIS Processes. So both of you are kind of the ideas are good in a sense that basically the idea on the course is really to teach you how to be how to learn or to learn how to do things that can be repeated. So that if you do a script that does now something and you want to repeat it for hundreds of thousands of data files, you don't need to do the clicking for repeatedly in ArcGIS, although there are some tools that you can also use to kind of do patch processing in ArcGIS, but of course this might be much more flexible and you can do much more sophisticated stuff using programming, as you said. So that is the idea, and yeah, that's good. And anyway, it's good to understand programming, as you said, many things, or you said many things are kind of working nowadays. The code is everywhere, so kind of understanding the basic principles of how things work in our world is quite crucial for you. So that's also important. Yeah, so why Python for GIS? So there are some kind of bullets that I have raised here. So what is nice is that everything is free. There is a lot of different tools available just for free, and they are open source, so you can actually go and see how things work in ArcGIS and some other these kind of commercial softwares. They are kind of black boxes, so you know that they kind of can do things, but you don't have any means of seeing what is actually under the hood. So how are these tools working? So everything is open in these kind of open source softwares, which is nice. And as you said, you will learn and understand much more deeply how things actually work. So in ArcGIS, for example, now I compare all the time at ArcGIS, but I don't really have anything against ArcGIS. It's a good tool, but maybe expensive. But still, you kind of understand better how things work, how those different tools are actually what they are doing. So you kind of get a deeper understanding of them. Yeah, then Python and Python GIS, it's flexible. I do it all the time with big data. For example, with social media data, so all the kind of analysis that we do is basically done with Python and Pandas actually, which is really efficient for large quantities of data. And then what else do we have? Yeah, then one cool thing, like if we compare, for example, Python to R, is that Python is really a fully established programming language, whereas R, it's basically a programming language, but it was developed originally for statisticians. So Python is much more flexible and much more comprehensive in many ways, although R is really good and comprehensive as well. But still, Python kind of beats it in that sense that you can do more stuff with it. And yeah, so we have already seen that there are different kind of tools and modules that we can use with Python. So you don't actually use the just basic Python programming language, but you actually can take advantage of different modules. And for GIS, there are many of them, and we will basically see quite a few and see how we can do stuff. The Matplotlib doing the kind of visualization, so it can be also done or used to do maps, and we will basically In GeoPandas, which is similar to Pandas, you can actually create a map just as easy as we did basic visualization in Pandas. So some data frame dot plot, and then it will actually create a map for you. So it's really easy, and that uses matplotlib. But basically there is a short list of different kind of tools that are available. You don't need to know them all. We will now, during these 7 weeks, kind of see a few of them and how they work, and then you basically know something. But of course, there are links to the documentation of each one of these, and I tried to make a short description of what these tools are used for. So you can actually click the links and check what they are really doing, and if you are interested, there are usually nice tutorials bundled with them, so you can actually do those as well and learn. But basically what we will use is, well, we continue using Pandas and GeoPandas. We will continue using matplotlib. Then the interactive stuff is done with Poke, which is quite nice for doing interactive visualizations. Then there is this GDAL library. It's kind of really fundamental package for any GIS related tools that are available. It's kind of similar that NumPy is for kind of data structures and such data analysis that runs basically on the background of Pandas. So GDAL is the same for GIS stuff. So it actually understands how to read data from different formats and so on. GeoPandas is the framework that we will mostly focus on. So we will use that for doing all sorts of GIS stuff. Shapely is a kind of really important Python package because it kind of has all the geometric objects and representations of those. So this will be actually the topic for today. So we will see how you can actually, as boring as it might seem, but you know how to create a point, how to create a polygon, and so on. But that is quite crucial information for doing GIS, so how to actually create these objects. Then there's Fiona, which is basically, well, something built on top of GDAL. PyProj is basically a module that handles all the projections. You don't really need to use it directly, it's kind of integrated into GeoPandas, but that is available. PySal is for spatial analysis functions. There is a lot of stuff included in PySal, and unfortunately we don't have time to go through all of them, but it is an interesting package for doing more sophisticated GIS analysis and those kind of things. So you might want to check that out if you are doing more sophisticated GIS analysis. GeoPy is something that we use for doing the geocoding, so converting coordinates to addresses and addresses to coordinates. GeoViews is pretty cool module for doing interactive maps for the web. And then what else do we have? There is quite a lot of modules related to plotting and doing maps, and they are all kind of, they have some specialty in each of them. Geoplot is nice for kind of doing maps with different projections and so on. Dash is really cool. I think I mentioned that already, but it's this kind of framework for building like real web applications, analytical web applications. So that's quite cool. Unfortunately, we don't have time to go and use that at least this year. Let's see what we do next year. OSM NX, that's quite cool. new module for doing analysis using street network data from OpenStreetMap. So you can do quite cool stuff with that. Network X is for network analysis, blah blah blah. Then there is for raster stuff, so I have also included those. So we have this Rasterio, which is this kind of nice wrapper on top of GDAL, and you can do raster analysis using that. And then there is this Ares GIS lib, which is for remote sensing stuff. So there's quite an extensive list of packages that might be used for different purposes, and they are listed here. So you might want to take a look of them, at least maybe later when you are applying GIS for your own problems.